Good morning, girls. Children, I started the exercise 6.2, chapter similar triangles, and I had explained question number 1 and question number 2. I hope you have completed the basic proportionality theorem, the proof, as well as the proof of the converse theorem. And continuing the exercise 6.2, I will now take up question number 3, 4, and 5. Okay. Now, starting with question 3, it says that in the figure 6.18, if LM is parallel to CB and LN is parallel to CD, then you have to prove that AM upon AB is equal to AN upon AD. So let's see the figure. AM in triangle ACB, yes, ML is parallel to BC, and in this triangle ADC, NL is parallel to DC. Now what do we have to prove? That AM upon AB, okay, is equal to AN upon AD, right? Now I've drawn the figure here. Yeah. This triangle ACB and ADC, ML is parallel to BC and LN is parallel to what? CD. Now let's see what is given. We know that we write LM is parallel to CB, and here LN is parallel to CD, and these two triangles we are going to consider now. Now when we look at this triangle ABC, in triangle ABC we can write by basic proportionality theorem, because we know that because LM is parallel to CB, according to the theorem we know that when this line is parallel to the third side, the sides are proportional. So therefore we can write AM upon MB is equal to AL upon LC. Okay. Now we can also write BM upon MA is equal to CL upon LA. Okay, both the ways we can take and we can try this proof. So let's start with we write AM. Let's go in the same order. AM upon MB is equal to AL upon LC, number 1, right? Now similarly in triangle, which one? ADC, we can write AN upon ND, yes, is equal to AL upon LC by 2, and we are applying the same theorem, BPT, basic proportionality theorem, and in this case you know that what is parallel? LN is parallel to CD. Now when you compare the equations 1 and 2, we will write by 1 and 2 we can write AM upon MB is equal to AL upon LC, AN upon ND, right? Now we have to prove that it is the ratio will be AM upon AB and AN upon AD, but here we've got AM upon MB and AN upon ND. Now in this we can write AM upon, for MB I can write AB minus AM, yes, and on the other side for ND I can write AD minus AN. I hope it is clear to you. For MB, let's check. For MB I can write AB minus AM, and for ND I can write AD minus AN. Now when we rearrange, okay, on rearranging the ratio, I can take this part, if I take on the other side and this on this side, we will get the reciprocals. So therefore on rearranging I can write AB upon AM upon AM, AB minus AM upon AM will be equal to AD minus AN upon AN. You understood what I've done? This part if I shift here and this part if I shift here, I will get the reciprocals of this. So therefore I can write AB minus AM upon AM and AD minus AN upon AN. Okay. Now I will separate the terms. Now when I separate the terms, wait, I will get AB upon AM minus AM upon AM. Yes. And what will I get on the other side? I will get AD upon AN. Yes. Minus AN upon AN. We can cancel this. We can cancel this. This will be minus 1. This will be minus 1. And so this will disappear. So we will be left with AB upon AM will be equal to AD upon AN. Yes. Again we can rearrange. On rearranging, we get, or we can take, yeah, on rearranging we will get AN upon AD. This AN will go here and this AN will go with AB. Or we can do one more thing. See, AB into AN is equal to AD into AM, right? So after this we arrange and we get AN upon AD is equal to AM upon what? AB. So this is complete and we can now write hence proved. So AM upon AB is equal to AN upon AD. Now I hope it is clear to you. Twice we'll rearrange. First we will first apply the basic proportionality theorem for these two, and then we will, by equation 1 and 2, we will get that AM upon MB will be equal to AN upon ND, as I've shown you here. Then after that we are going to write for MB, I can write AB minus AM. And again on rearranging, this is the first time we are rearranging, and therefore AB minus AM upon AM, AD minus AN upon AM. Then we separate the terms, and after separating we get minus 1 both the sides, which we cancel, and therefore AB upon AM is equal to AD upon AM. But we want, in the question we want AM upon MB, AM upon AB and AN upon AD. So therefore what I do, I will first cross multiply and then rearrange the terms, the lengths we can say, and therefore AM upon AB is equal to AN upon AD. This completes your proof. If there is another method, you can show it to me and then we can check it out. Okay. Now, coming to the next question, question number 4. In the figure 6.19, this one, it's given that DE is parallel to AC, fine, and DF is parallel to AE. We have to prove that BF upon FE is equal to BE upon EC. So the question is of the same type, yes, slightly differing in the figures. Okay, now check. I have drawn the figure. Let's start. In the figure, we know that this is A, B, C. Fine. A, B, C. DF, we write. DF is parallel to what? AE. Yes. And DE is parallel to AC. Okay. Now same thing we can apply here. Let us take the triangle first. A, B, E. Okay. Now in triangle ABE, we know that by basic proportionality theorem, since DF is parallel to AD, I can write BD upon DA, okay, BD upon DA is equal to BF upon FE. BF upon FE. I hope it is clear to you that for triangle BAE or ABE, BD upon DA is equal to BF upon FE. Now we will consider the complete triangle ABC. Okay, when I take the whole triangle ABC, I will get BD upon DA will be equal to what? It will be equal to BE upon EC. Okay, so I hope it's clear to you. Now in triangle, which one? The whole triangle ABC. Children, when I'm solving this, you can keep the figure in front of you, means the book should be open, and then the steps will be clear to you. So now in triangle ABC, as I told you that DE is parallel to BC, so I can write BD upon DA. You can check here. BD upon DA is equal to what? BE upon EC, number 2. Okay, and what we've got in the first one, we have got BD upon DA is equal to what? We have got BF upon FE. So therefore by 1 and 2, we will get, since BD upon DA is equal to BE upon EC, and in the previous equation also BD upon DA is equal to what? BF upon FE. Therefore we'll write BE upon EC is equal to BF upon FE. You can check out here. BF upon FE is equal to BD upon DA. So therefore we now get this as the complete proof, or we can write BF upon FE is equal to BE upon EC. Hence proved. Yes, so these sums are easy. The only thing is, you should know how to apply the basic proportionality theorem. Now one more sum I'll do. The next question is fifth one. You can see the figure here, PQR, and here you have to show that EF is parallel to QR. Okay, we have to show that EF is parallel to QR, and what is given in the question, it is given that DE, now this is the point D. Okay, you know that DE is parallel to OQ, yes, and DF is parallel to OR. When the lines are parallel, children, then only we can apply the basic proportionality theorem. Now coming to this triangle POQ, in triangle POQ, since ED or DE is parallel to OQ, what we can write? PE upon EQ, yes, is equal to what? PD upon DO. PD upon DO, number 1. Second, the triangle will be in triangle POR. Yes, in triangle, wait. In triangle POR, same, PD upon DO. PD upon DO is equal to what? PF upon FR. Yes. So same thing, on comparison, or when we compare these two, PE upon EQ is equal to PD upon DO, and PD upon DO is equal to PF upon FR. So therefore again by 1 and 2 we will get PE upon EQ is equal to PF upon FR. Now I come back to the question. PE upon EQ, PE upon EQ is equal to PF upon FR. Now since the corresponding sides are proportional, therefore we can write EF, right? We can write EF is parallel to QR. Hence proved. This is what? That when the sides are proportional, the lines are parallel. This line is parallel. So therefore, we have proved that PE upon EQ is proportional to or is equal to PF upon FR, and therefore, since the corresponding sides are proportional to each other, therefore EF is parallel to QR, and this completes your question. Now children, today I have completed with you question number 3, and here I have done question number 4 and question number 5. Okay, so this is the complete proof of the 3 questions. If you have any doubt, you can ask me, children, and tomorrow I'll continue with the next set of questions. Okay, any doubt, children, you can message me, and see that you complete your work on time. And thank you. Have a good day.